Welcome to this unusual problem about limits of accuracy, upper bounds, lower bounds, significant figures, rounding. It's all involved in this question. So Dave returned from a mountain biking journey and said that the time for the journey was 94 minutes and the distance was 17 kilometers. Emily said that she completed a journey of 17 kilometers in a time of 93 minutes. So by considering limits of accuracy, we've got to state which of the following are true, and there's 6 statements there. We won't go into those at the moment. We'll look at the numbers we're dealing with, and we'll start to work on the problem by considering the bounds, upper and lower bounds. Now, the first thing to notice is that there's no degree of accuracy given in these measurements. Dave said it took him 94 minutes, and the distance was 17 kilometers. Now, because of that, we can assume that the 94 minutes is to the nearest minute and that the 17 kilometers is to the nearest kilometer. You see, if he had said it has taken him 17.2 kilometers, right, then you could conclude that it was between 17.15 and 17.25. But because he's given it to the nearest whole number, you can assume that it's come from 16.5 to 17.5 kilometers. All right. And for the time, you can assume it's come from 93.5 to 94.5 minutes. Okay. So what I'm going to do is I'm going to work out the speed, and we're going to use the fact that distance speed is distance divided by time. Okay, there's a little thing that you may have seen, which is a little sort of triangle to help us remember this. I'll just put it up here. So it's a sort of a triangle like this, and what we do is we say that speed equals, I'll show you how it works. That goes across there, and there's a line down the middle there. And what we do is we put in there that speed times time is distance, okay, like that, and then we use the whole thing in reverse, so speed is distance divided by time. Okay, right, now there is another complication because we're looking here at kilometers per hour, okay, and the question is given in minutes, so there's going to be a factor of 60 involved somewhere. But the key thing is we need the bounds. So what I'm going to do is I'm going to write down a few facts about Dave's journey first of all. Okay, and I'm going to put that 93.5 is less than and including 94, which is less than and including, less than, not including 94.5. Okay, that's what's called the limits of accuracy for the time of Dave's journey. And for the distance, of course, it's going to be 16.5, okay, is less than and including 17, which is less than and including, not including, less than 17.5. Okay, so they're the lower bound and upper bound of the time, the lower bound and upper bound of the distance. Now we do the same for Emily, but in fact this part's the same, okay, but it's the first part that's going to change. It's going to be 92.5, okay, less than or equal to 93, which is less than 93.5, okay, and for the distance it's the same as in Dave's case. Now, okay, so we've got to now consider what the speed is. And when you're dealing with bounds, if you have a division, to get the maximum speed and you have a division, you need to maximize the top number, the numerator, if you like, and minimize the denominator. Okay, that will give you the maximum value for the speed. So So we'll just now consider the speeds. Now I could do a little table here. Actually, it doesn't take long, and it might be worth doing in your exam question if this was what you were doing. So let me just quickly sketch a table. Okay, and we'll put everything in there that we need. So we've got to do 4 things we need. We want the minimum and the maximum speed for each of Dave and Emily. All right, so 4 different calculations with 4 different answers. So if I just quickly label this as Dave and Emily, and it's minimum and maximum. Okay, for the speed this is. Okay, so let's look at Dave first. The minimum speed, that's going to occur when we have the minimum distance, which is 16.5. Okay, and we're assuming that the time was at the top end, 94.5. Okay, but we need to times that by 60 because that will turn it into kilometers per hour. So basically that would give how many kilometers he did in a minute, times it by 60, it would give an hour. Okay, and this would be 17.5. Okay, that's the maximum possible distance divided by the minimum possible time, which is 93.5. Okay, and again times 60. And then we have the third one here, which is Emily. Now this would be her minimum speed, right, which is her minimum distance, okay, which is also 16.5, divided by her maximum time, which is 93.5, okay, times 60. And finally we're going to have 17.5, okay, divided by her minimum time, which is 92.5, times 60. So by doing a little table you get some kind of pattern or order. Now if you put those 4 things onto a calculator and then give the answers to a reasonable number of decimal places, so I'm going to actually give each one to 5 significant figures, so 3 decimal places. Okay, so this first one comes to 10.476. Okay, I'll put these in a different color. 10.476, and it's not rounded, so it just carries on. They're just the first 3 digits off the calculator after the decimal point. This one comes to 11.229. So these are speeds in kilometers per hour. 11.229, and I think it then goes 9 again. But anyway, that's enough accuracy. Then we're going to this one, which is 10.588. 10.588. Okay, and the final one is 11.351. Now what we have to do now is carefully interpret these in the context of these statements. Dave's average speed was 11.0 kilometers an hour. Okay, not true, because these numbers for Dave, if you rounded that is rounded to 3 significant figures to 1 decimal place. Well, 10.4 and 11.2 are way different from each other to 1 decimal place. So that is definitely not true. Okay, the second one, Dave's average speed was 10 kilometers an hour to 1 significant figure. Right, well that's simple to answer. What's 10.476 to one significant figure, it's 10. 11.229 to one significant figure is 10. Okay, now to two significant figures it's 11, all right, but it's not, it's one significant figure, so it's 10. In fact, if that had been 14.5 to one significant figure, that would be 10. In fact, if it had been 14.999 to one significant figure, that's 10. So this statement is actually true. Dave's average speed was 11 kilometers per hour without referring to a degree of accuracy. Again, it implies that it's two significant figures of accuracy. Now, this is 11 to two significant figures, all right? But unfortunately, this one isn't quite close enough to 11 because it's 10.4, so that to two significant figures would be 10, not 11. All right, so had this been 10.576, then this statement here would be true, all right, because both 10.576 and 11.229 both round to 11 to the nearest whole number, okay, or to two significant figures. So this is wrong in the case of Dave. If that had been about Emily, then it would have been true because 10.588 would round up to 11 and 11.35 would round down to 11. That statement would have then been true if it was for Emily. Okay, Emily's average speed was greater than Dave's. We don't know the answer to that. Yeah, obviously it appears that she was faster because she did the same distance a minute quicker than he did. Okay, but the thing is, her average speed could have been as high as low rather as 10.588, whereas Dave's could have been as high as 11.229. So his average speed could have been faster than Emily's based on the limits of accuracy. So we can't, that is wrong. We don't know whether it's greater or not, but you can't say it is greater, so therefore that statement is wrong. Dave's and Emily's average speeds were the same. Well, again, clearly we can't say that. So it's possible that within that, they're both within that range, so they could have both been exactly the same to say 3 or 4 or 5 significant figures, but after that there could be a difference. You can't say that they were the same. And Dave and Emily both had an average speed of 11 kilometers per hour. Well, as we've discussed earlier, Emily did, but Dave did not, because that's given to two significant figures, and Dave's could have been this, which would have therefore made it 10, not 11. So that's not true either. So the only statement in there that is true for certain is statement B. Okay, and that is the end of that question.